Good question morning, neighbors. Let's see what I did to the audio here. Neighbor asked a question related to Fukushima designs and the failure, one specific failure of engineering at Fukushima. So the Fukushima TEPCO plant was very basically designed by General Electric, but it was TEPCO that is the owner of the plant. So under TEPCO are subcontractors. General Electric would be called a prime contractor, building major portions of the contract. So this is engineering before the plant's even been approved. There's people in the background studying and looking and where to put this and how to do it, and there might be a year's worth of work leading up to the beginning of work. You know, a multi-million-dollar investment in building a billion-dollar plant facility somewhere. So anyway, inside of that are huge engineering houses. These are buildings full of engineers that their only jobs are designing these huge facilities. These are Bechtel, General Electric, DuPont does this type of work in the background, subcontractors, LLCs, limited liability corporations. So these things are, a facility that size is a huge string of engineering processes, of human processes to put things and people and machinery and computers and controls and software together. So back there are multi-million-dollar engineering houses. And mind you, there's only a few on the planet capable of doing these. America has 3 or 4 at this point in time. France, Russia, Japan actually makes a lot of nuclear components. They have nuclear engineering in-house capabilities. But these are all little, I say little, multi-million-dollar companies handing each other contracts. So at the beginning of this Fukushima thing, a design basis document, these are the fundamental criteria for building the plant, is developed. And from this, engineers go back and look at this. And at this level, you're in senior engineering loops. You're in people that have invested lifetimes in education and experience and training to make decisions and look at these things and put them together and take them apart and put them together again so they can be maintained after they're built. These little questions are huge questions. They affect the cost and expense. If you know you have to rebuild half the plant in 3 years, you're in trouble. Your design basis is flawed. So back to the design basis. This is a huge document that points to hundreds or thousands of other documents. Somebody in there was contracted to do the seismic studies, the geological studies, the water flow studies, how the soil mechanics and the earth mechanics, the earth sciences for that location on that island and its susceptibility to things. So in that design basis document, you can go back and find the articles on it now, and if you want further, you can go back and find some of the conversation details, the I was there documents, the meeting minutes, the notes passed back and forth. They did find signs of a tsunami that exceeded the design, what everyone was talking to for normal sea level activities. These things are considered. Remember, we have 10,000-year floodplain documents for the United States of America that set floodplain insurance rules. We kind of know how the tides ebb and flow because we've been on this planet for 200,000 years in kind of this life form, and longer than that in other forms. So these changes we know about. Someone downplayed that tsunami wash on a wall from 10,000 years ago. You can use your imagination to wonder how that was justified. Some people don't think 10,000 years ago is real or exists. So you can cause churn and consternation inside a conversation. But what happens is that design basis document never mentioned an additional 40 feet tsunami potential. That engineer sitting in a design building somewhere, a tower of knowledge out there in the corporate blogosphere, that designed that engineer may have never seen the potential for that extra 40-foot tsunami wave. He never would have thought or been required to engineer for it. It wasn't in his design basis. And he was one small cog in a massive wheel. His only responsibility might have been air handling systems, shared facilities for a, what was that, a 4-reactor nuclear equipment set has shared facilities. Those diesel generators are part of shared facilities. So that might have been the only area he was in, was designing secure, this is called facilities. This is capital expense and ongoing operations. For every one of these checks, you need to check, and you need a person, and you need people and time to do it. So there you go. That's how these things happen and slip. To go back to that engineer should bring up a conversation like this. He flat did not, was not required to engineer to an extra 30-foot or 30-meter, 90-foot, whatever it was, tsunami threat. It simply was not in the risks lists that he went through and were spoken through and worked through. So there's the simple answer to, well, it's not simple, it's very complicated. This is how engineering can be segmented, compartmentalized, so that some of these things just in process get overlooked. A conversation in the hallway. Hey, did you notice any other tsunami concerns? Any high wave concerns? Seismic concerns? You see, that engineer sitting in that one tower wasn't the engineering group that did the seismic design and study and takeout. He's going to see the Reader's Digest condensed version of that document. But to blame the lowest common denominator is very common in engineering. It's an easy way, it's an easy escape for poor management decisions. It is a hindsight review of we should have done better, and a lessons learned that gets carried forward institutionally. Lessons learned carried forward. That's kind of the human thing we do. This one's getting too long. I could go into Department of Defense, glass vitrification, low-level nuclear waste control interlock designs, and the importance of senior engineering professionals evaluating systems design. But that would be a longer video, so maybe I'll save that. Hope this helped. It's how these things work. And you can be segmented, isolated, neutralized, put in your place, missed a promotion for bucking some of these systems. So engineer on. Thank you for listening.